Hello everyone, I am Vyas, and in today's video, we are going to talk about an important data science technique for handling imbalanced datasets called SMOTE, which stands for Synthetic Minority Oversampling Technique. By the end of this video, you'll know exactly what it is, why it is needed, and how to implement it in Python. In real-world classification problem, the dataset is not balanced. That means one class, called the majority class, has far more data points than the other, called the minority data class. For example, in our fraud detection, 98% non-fraud cases exist and only 2% are fraud transactions. Or in medical diagnosis, only a small percentage of the patients have the disease. This imbalance causes a serious problem. Your machine learning model can become biased towards predicting the majority class simply because that's what it is seeing the most number of times. Now let's take a credit card fraud detection example. Here in the datasets we have around 10,000 transactions and only 100 fraudulent cases, which roughly translates to around 1% fraud rate. So meaning the 9,900 transactions which are non-fraud transactions is your majority class, and the 100 transactions which are fraud transactions is your minority class. Now imagine you are building a model that always predicts non-fraud. It will be correct 9,900 times out of the given 10,000 transactions, which gives you a 99% accuracy. Sounds impressive, right? But here's the problem. The model never detects any actual fraud. So despite having a high accuracy, it is useless for the real-world task. That's why we have other metrics like precision and recall, which gives us a more complete picture. Now let us look at the credit card fraud example and understand what is the precision and recall is. So here you see the confusion matrix. In the confusion matrix, we have true negatives, false negatives, and true positives. Your true negatives are nothing but these are non-fraud transactions, and our model also predicted them to be non-fraud. That is 9850 in our case. Your false positives are these are not fraud transactions, but our model predicted them to be fraud transactions. Next is false negatives. These are actually fraud transactions, but our model predicted not fraud. And finally is the true positives. These are also fraud transactions and our model also predicted them to be as fraud. So here in this case, accuracy will be all your true predictions, that is true negatives and true positives, that is 9850 plus 10 divided by the total number of transactions, which is comes to around 98.6. So for this model, we are getting around an accuracy of around 98.6, which sounds impressive. But let's look at precision and recall. Your precision is nothing but your true positives divided by the true positives plus false positives. Your true positives are 10 and false positives are 50. So 10 divided by 60, which is 16.7. So precision tells us of all the cases we predicted as fraud, how many were actually fraud. So basically we predicted there are 60 fraud, but only 10 are true fraud transactions. So 10 divided by 60, which is 16.7. Now let's look at recall. Recall is again true positives divided by true positives plus false negatives. Here we have 10 true positives and 90 false negatives. So 10 divided by 100, which is around 10%. So what recall tells us is of all the actual fraud cases, how many did we correctly identify? So basically we had around 100 false fraud transactions, and out of which we were only able to identify 10. So giving a recall of around 10%. So here you can clearly see that even if accuracy is high, both precision and recall are really low, showing that the model is performing poorly on the minority class. And this is exactly where resampling techniques like SMOTE can help. They give the model more balanced exposure to both class, so precision and recall can improve. So SMOTE is a technique to create synthetic data points for the minority class. So instead of just duplicating existing minority samples, which can lead to overfitting, SMOTE generate new, slightly different samples by interpolating distance between the existing ones. So here how it works. For each minority class example, SMOTE finds its k nearest neighbors, and by default k is 5, so it finds 5 nearest neighbors from the same class. It then picks one of the neighbors and creates a synthetic data point somewhere along the line between those 2 points. This way, you're not just copying the data, you're creating realistic new examples that help the model learn better decision boundaries. So before SMOTE, this is another example where we have a majority class of 85% and the minority class is around 15%. And after applying SMOTE, you'll see more balanced clusters with synthetic points filling in the gaps, making the distribution between classes much more even. So after applying SMOTE, the majority becomes 50% from 85%, and majority and minority and the synthetic data points become 50%. This balance helps your model pay equal attention to both classes, improving recall as well as overall predictive power. Like any technique, SMOTE also has pros and cons. Some of the advantages are it can significantly improve recall for the minority class. It prevents simple duplication, which reduces the risk of overfitting compared to basic oversampling techniques. And some of the disadvantages are it can introduce noise if applied blindly, especially when the minority class has outliers. Also, it can create borderline samples that are hard to classify. So it is important to apply SMOTE thoughtfully, sometimes in combination with other undersampling the majority class. In Python, implementing SMOTE is a straightforward task thanks to the Python library already available. Here's a quick example. Here, X is your feature set and Y is your target variable. After applying SMOTE, X SMOTE and Y SMOTE will contain the balanced datasets with the synthetic minority class points. Once you have done this, you can feed the resampled data into your machine learning pipeline as usual. That's how easy it is to implement SMOTE in Python. So that's SMOTE in a nutshell, a powerful way to tackle imbalanced datasets and make your model more effective at catching those rare but important cases. If you found this video helpful, don't forget to like, subscribe and share it with your fellow data enthusiasts. I am Vyas from Vyas Data Labs. Thank you for watching and I'll see you in the next one.